Besides shifting one of our parent functions side to side or up or down, another way to transform them is with a vertical stretch or vertical compression. So to illustrate this, we'll go on to the graphing calculator. Now I have as the parent function y1 equal to the square root of x, so that's our plain square root of x function, and then y2 is 7 times the square root of x. Again, I've got the standard viewing window, -10 to 10 on both axes. If I go and graph, there's the parent function, the bold, and there's the 7 times the square root of x. That's our new transform function. So you can see that it's been vertically stretched, or you might say it's narrower or steeper. So that's a vertical stretch by a factor of 7. So if we make a little sketch of that here in our notes. So here's our parent function, square root of x. When we put that 7 in front, it's going to stretch it up. And then if we put in front, instead of that 7, if we put a number that's between 0 and 1, such as 1/2, so if I insert here a 1/2 or a 0.5 in front, instead of that 7, so I've still got the parent function is the bold, there's the parent, plain square root of x, and then when we put the 1/2 or the 0.5 in front, you can see that this is wider or less steep or compressed, a vertical compression. So if we put that over here in our notes, so it kind of flattens out there, y equals 0.5 times the square root of x. So that's our vertical stretch and compression. So it's a stretch. It will appear narrower. Again, these are not mathematically formal terms, but this is just descriptive, what you'll see, narrower or steeper. And if it's a vertical compression, it will become wider or less steep. Okay, so let's review what we did to the equation. So if we take our function, our parent function, f of x, and we multiply, now notice we're multiplying outside the grouping symbol with those square roots, so notice we're multiplying on the outside of the function. And let's note here that our a is greater than 0. We'll talk about negatives here shortly. So what we did was we multiply outside the grouping symbol. So when we multiplied by the 7, so if the a, the constant out in front that we're multiplying by, if a is greater than 1, we're going to stretch it by a factor of a. So in our red example here, we stretched that parent function by a factor of 7. And then if our a is between 0 and 1, such as the 0.5 that we multiplied by here with the green one, we're going to compress by a factor of a. So our stretch, if it's greater than 1, compress if it's between 0 and 1. And if we look at the table of values, we go into our table, we can compare the y values for each of our functions. So here's our parent function, and here's our new function. This is the 0.5 radical x. This is just the plain radical x. And you can see all the y values are half. So here's our parent function 1. Then in the new function, it's only a half. Here, the y value is 2 in the parent function, and it's only a half. So all these y values of the parent function are being multiplied by that 0.5, that a.